We're looking at area of parallelograms and triangles. So area of a parallelogram, you've seen this in the form of area of a rectangle, which is a parallelogram, is that the area equals base times height. And area of a square, it's the same thing as side times itself, or side squared, just because they're the same length. What is tricky is when you have a parallelogram like this, it's not, the height isn't just one of the sides. The height is the perpendicular height. The height's the perpendicular height, not just one of the sides. So you have to make sure that's the value you're using when you multiply. You have the little 90-degree box, so that means the height meets the base at 90 degrees. Or you can do it from the outside. It doesn't really matter. And then the same with the triangle. The height of the triangle has to be perpendicular to the base, or else it's not a true height. Triangles also have something, or a pyramid has something called a slant height. We'll get to that when we get to 3D figures. But we are looking at the perpendicular height. You need the true height, which is perpendicular to the base, is the perpendicular height, or the true height. And so the area of a triangle is 1/2 base times height, so it's half of the area of a parallelogram. Or area equals base times height divided by 2. It's the same thing, whether you write it as 1/2 or divided by 2. All right, so here we're going to find the area, show work, write the formula. Don't forget to square the units. So linear units are inches, meters. That last one doesn't have any units on it. So area, the units are going to be inches squared, because it's going to be inches times inches, so it's inches squared. Meters squared. So make sure you have that. A rectangle is a parallelogram, so area equals base times height. That's the formula. We can see we have two numbers, but those are not the base and the height. We do have the base. Here the base is 12. But the height has to be perpendicular to the base. So the height is going to be that piece over there. So the 13 is we're going to use the 13 to find h by using the Pythagorean theorem. Because now we have a right triangle, like if we just look at the bottom section, 90 degrees to the 13. That makes the 13 the c of the triangle. So a squared plus b squared equals c squared. But a and the b don't really matter as long as c is the 13. So first, before I can do area, I have to solve for the height. So the height, h squared plus 12 squared equals 13 squared. And since the c value is always the largest side, I know my number needs to be smaller than 13 in the end. I like to solve for these by subtracting the 12 over first. So that's what I'm going to do. I'm going to subtract 12. So h squared equals 13 squared minus 12 squared. And I can type that in the calculator. So h squared equals 25. So because I recognize that my h has to be smaller than 13, it's a clue that I'm not finished yet. I have to take the square root of 25. It's not just h squared. I want to get rid of the squared, so I take the square root of both sides. Square root, squared cancel out. So the height is 5, not 25. So h is 5. Now I have a base and a height. So I can go to the area formula. Base times height. I know the base is 12. I know that the height is 5. 12 times 5 is 60. So the area equals 60, and these are in inches, and the inches are squared. because the area is how much space to fill up that rectangle. 60 inches squared. So not just the outline, but a filled in shaded space. All right, so number 2 is similar. It's a parallelogram. So we're going to have the same formula. The area equals base times height. And we see the H has, we have a designated space for H, but we still don't know what it is. We know it's this section. There it is. We have the 90 degrees, but we don't know what the value is. And so that means it's perpendicular to the base. So together, 4 plus 8 gives me the base. So the base is 12. All right, so if I go ahead and start working with area equals base times height, I don't know what H is, but I do know that B is 12. I can fill that part in. And then I need to look at this triangle to figure out what the height is. So I'll need to use the 4, the 8, and the H. Or use the 4 and the 8 to solve for H. All right, so I have H squared plus 4 squared equals 8 squared. I know 8 is going to be my largest number. So 8, the height is less than 8. I know that much. And then I want to subtract the 4 over. So H squared equals 8 squared minus 4 squared. So then H squared equals 48. Okay, so if I take the square root, that's not a perfect square. So I'm not going to do a decimal. Instead, I'm going to write it as H equals the square root of 48. Now to simplify the square root of 48, I can use a factor tree and break it down into its simplest factors and circle the pairs and square the spares, or however it is that you're taught to do that. But I think the easier way, the way of less work, is to make a list of perfect squares up to that number. So, let's see. The pen just stopped working. Oh, that's weird. All right, 2 squared. Sorry, having technical difficulties. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. So I know I'm not going to have anything larger than that because I'm dealing with H is the square root of 48. 49 is larger than 48, so I can stop. I don't need anything bigger than that. In fact, this number is too big also. But that's okay. All right, so looking at my list, I want to find the largest perfect square that I can divide 48 by. And take a whole number, no decimals. 48 divided by 49, no, that's silly. 48 divided by 36, that's a decimal. It doesn't divide evenly, so it's not that one. 48 divided by 25, it's going to give me a decimal, so it's not that one. 48 divided by 16.
3.
Yeah, 48 divided by 16 is 3. That's a whole number. So 16 is the one I'm looking for. That's the winner. So if I choose this one, I take this square root of 48 and I split it up. 48, oops, not 48, 16 and 3. because 48 is 16 times 3. And with radicals, you can split the radical into pieces. So I'm going to make it h equals the square root of 16 times the square root of 3. And I know that the square root of 16 is 4. So h equals 4 square root of 3. 4 times the square root of 3. And that is simplest terms. You won't have to do that on every problem, but I will expect that you know how to do this. Find the biggest perfect square that you can divide your number by and get a whole number, and then take the square root of that number and whatever's left over, leave it as the leftover. So the height is 4 times the square root of 3. All right, so that's 4 square root 3. All right, so now I need to finish the area. Area equals, so how do I multiply that with just a regular plain number, 12? Well, the 12 and the 4, those are like terms. So I'm just going to multiply the 12 and the 4 together. That's 48. And then just leave the square root of 3 as the square root of 3. Don't do anything with that. And this is meters squared. So you just multiply the parts that are the same. Okay, so then the last one on the side of the paper is a triangle. This one's nice. The height and the base are already perpendicular to each other, and they're both given. So it doesn't matter which one you call base and which one you call height. I'm just going to go ahead and call that one the base, and this one the height. The formula for a triangle is area equals 1/2 of base times height. So the area equals 1/2. Fill in the blanks. Base, 6 times the square root of 3. Height, 4 times the square root of 3. All right, so I'm going to need to multiply these together. So just like the end of the last problem, the 6 and the 4, those are like pieces. I can multiply them together. That gives me a 24. Then I have a square root of 3. And I have another square root of 3. I'm just doing this one step at a time. And when you agree that square root of 3 times the square root of 3, I could call that the square root of 3 squared. So a equals 1/2 of 24. And I could just call that the square root of 3 squared. Because when you square something, you're multiplying it by itself. So square root 3 times square root 3 is square root 3 squared. And whenever you square a square root, you cancel it out. So really, I just have the area equals 1/2 of 24 times 3. Well, 24 times 3 is 72. So the area equals 1/2 of 72. And that is 36. So the area equals 36. And I wasn't given any units, so I cannot, I guess I could write units squared, but I'm just going to leave it as 36. All right, so then on the back, I have 2 more examples of different kinds of problems. We have another triangle. And there's a blank, empty triangle picture. It says, find the area of an equilateral triangle. That's a very specific kind of triangle. With a perimeter of 18 centimeters. So if you remember equilateral triangle, that's a very specific type. That means that all the sides are the same. Equilateral. All 3 sides are the same. And the perimeter is 18 centimeters. So the distance around this triangle is 18 centimeters. And if I split it evenly in 3 directions, or 3 ways, 18 divided by 3, because it's all even, gives me 6 centimeters. So each side of this triangle is 6 centimeters. All right, and I want the area, and area equals base times height. Oh, 1/2 of base times height, because this is a triangle. So the area is 1/2 with blanks. So clearly I know the base, right? The base is 6. It doesn't matter which part I call the base, but I can call the base 6. Then I need to find the height. So at some point, I just tend to go to this part of the triangle. It doesn't matter where you do it. It can be on any of the 3 sides. You need the perpendicular height. The height. So if I do that, that means I take the side of 6 and I split it up into 3 and 3. So now I look at my triangle within the triangle to use Pythagorean theorem. I have a right triangle inside the large triangle. And I can use Pythagorean theorem on that to figure it out. So I'm going to do h squared plus 3 squared equals 6 squared. So the height has to be less than 6. So h squared equals 6 squared minus 3 squared. So h squared equals 27. Again, that's not a perfect square, but I can do the square root of it to get that h equals the square root of 27. And 27 is really not that bad of a number to work with because there's not much that you can divide 27 by, right? 9 and 3. 9 is a perfect square. So h equals the square root of 9 times the square root of 3. That would be the square root of 27. And the square root of 9 is 3. So h equals 3 times the square root of 3. So I put that in here. Calculate this up. So this equals 1/2 of 6. Remember, the 6 times the 3 is 18. So it's 18 square root 3. So the area equals 9 times the square root of 3, because half of 18 is 9. And this is in centimeters, and it's area, so it's centimeters squared. And then the last type of problem I have is one that can be done on a graph, and I feel like those make it pretty easy. But you don't have to do it on a graph. If you'd rather just work with the numbers, you can do that too. I will show you both ways. Here we have A, B, C, D, so I'm going to plot the points. A is at 4, -2. B is at -2, -4. C is at -2 and 1. And D is at 4 and 3. All right, so this is a parallelogram. So the area equals base times height. So it's going to be blanks. Blank times blank. Now, whenever you graph a picture, if you have a straight horizontal or directly vertical, either vertical or horizontal, you just count the boxes. So that makes this height from B to C or C to B. Since it's just a straight line, it's a vertical line, you just count those boxes and call that the height. So the height here is 5. So h equals 5. The height is also with the y's. So if you wanted to just look at point C and point B and the y values, -4 and 1, the distance from -4 to 1 is a distance of 5 boxes or 5 spaces. So the height is 5. So there's 2 different ways to do that, calculate the height. You can count the boxes if you graphed it, or you can just look at the y values. If their x values are the same, -2, -2, then you just look at how far away are the y values from each other. And then the other is the x values, or the base. You can look at the base. As long as it's perpendicular to the height, it doesn't matter where you count it. You can count it right there along the x-axis if you want to. You could go from this point all the way over to here if you wanted to. It doesn't really matter. And if you count the boxes, there are 6 boxes, so B equals 6. The same from B to A. If you notice, the distance 4 to -2, that is 6 spaces. So the area is 30 units squared.